the capital asset pricing model, the Chapter 9 material. We're going to skip a bunch of the math used to derive the CAPM, and we'll just sort of describe the derivation instead. So, given that we have n risky assets and n expected returns and n standard deviations, each stock has the statistics associated with it. In addition, we have n squared minus n over 2 cross terms or covariances and 1 risk-free. So this is our data set. We use the Markowitz separating property to find the best risky portfolio P. And we can consider the aggregate of everyone's holdings must be the market portfolio. And so if we do this with some number of stocks n, then we get P, but if we do this with everybody's stocks, it becomes M. And so P, this risky portfolio of n stocks, actually becomes M, the market portfolio. And so instead of having a CAL, a capital allocation line for some risky portfolio, we just change the name and we refer to this as the capital market line for the entire market portfolio. So the capital allocation line becomes the capital market line, P becomes M. And the difference is just this sort of theoretical assumption that we make that we're going from some large number of stocks N to every stock M. So here's some assumptions of the capital asset pricing model. If it is the case that the aggregate of everyone's portfolio is the market portfolio, and everybody has the same expectations, everyone has the same expected return and standard deviations and correlations written down, and everyone acts rationally, all will be on the efficient frontier. Everyone will choose some allocation of the market portfolio such that they end up here on the efficient frontier. And the portfolio that everyone chooses is this market portfolio because it's optimal. We've shown it before. And the aggregate is the market. And the allocations that people choose of all of the many, many assets in the markets, the weight of the first asset, the weight of the second asset, the weight of the third asset, and so forth, is what determines corporate size and determines each stock's place in this market portfolio. Now, just talk briefly about some ideas here. A normative test of sort of a model or a theory is to examine the assumptions. Is it the case that the assumptions hold water? And a positive test, these are things that can be tested, and we can therefore examine the predictions of the model. And so even if the assumptions necessary to write the model down don't hold, and a lot of these obviously don't hold, obviously we don't have homogeneous expectations and not everybody holds the same model, but once, the same portfolio, but once we write down the model, we can actually examine the predictions of the model. And so some of the normative tests for the CAPM fail, but maybe not the positive tests. So just because we had to come up with a bunch of silly assumptions to write down the model doesn't necessarily mean the model is wrong. One more important thing when it comes to examining a model, just because the model doesn't tell me everything doesn't mean the model tells me nothing. I could have a model of a set of buildings, and the model of the set of buildings might show me what shadows might look like or what wind through the buildings might look like. It's not going to help me much with the plumbing structure, but it doesn't mean that this architectural model tells me nothing just because it doesn't tell me everything. And this is true with the capital asset pricing model and really all financial models. And so let's just be clear that there's a lot that the capital asset pricing model can tell us. There's a lot that it can't tell us, but just because it doesn't tell us everything doesn't mean it tells us nothing.